Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate
I want to talk about conic sections. Now those may seem weird or sound odd, but you've actually worked with conic sections already, at least some of them. So I want to show you what they look like and how we can sketch them. So conic sections represent some equations or functions that are actually considered some of like the oldest aspects of math study. It's said that they were discovered by a Greek mathematician named Menaechmus, and he lived to be in the time period of 375 to 325 BC, and who was a tutor to Alexander the Great. So these sorts of math equations were conceived as an attempt to solve three of the famous problems at that time of trisecting an angle, duplicating the cube, and squaring a circle. So a conic section, though, is formed when you take a plane and you slice it through what's called a double napped cone. This is a double napped cone. The cones themselves are called naps, and we have some characteristics here. So this right here is the vertex. It does have an axis that goes through the center here, and this is considered the edge of the cone. So what I want to show you is what happens when we take a plane and we slice it or intersect it through this double napped cone. Now, if the intersection of the plane and the double napped cone form a point, a line, or what's intersecting lines, then we consider those degenerate conics. Now, there's four possible situations that can happen here. So let's start with the first one. The first thing we have to do is draw a double napped cone. The easiest way to do it is draw two lines like this, make an X, and then you're going to draw a circle up top and a circle on the bottom. Now you have your double napped cone. The first situation is if the cross section is in one nap or one cone and is perpendicular to the axis. Okay, so remember, the axis is the line that goes through the double napped cone. So this first slice is going to go through one of the naps, so one of the cones, and is going to be perpendicular to that axis. Something we have studied. We've studied circles. This time, our slice is going to only be again in one nap and for one cone, but this time it's not perpendicular to the axis. So again, I'll just focus on the upper one. It doesn't matter, by the way, which cone it's in, the same thing will happen. What shape do you think that is? It's not a circle. It's going to be an ellipse. Here's our third one. This time the slice, again, is only going to be in one nap, so one cone, but it's going to be parallel to the edge of the cone. So the curve that's created here is a parabola. So we have a parabola there, something again we are very familiar with. In this last slice, it's going to go through both naps this time, so both cones. but it's going to be parallel to the axis. Is I create something called a hyperbola. So when you graph a hyperbola, literally there are two branches there that are evident in there.